In Math 13-16 class, the first chapter is called Trigonometric Functions, and it has 4 different lessons. We're going to start today with 1.1, and it's called Angles. I'm going to model you some examples from the first homework assignment. First question is asking about complementary angles and supplementary angles. If 2 angles add up to a 90 degree, we call these angles as complementary angles. If the 2 angles they add up to 180 degrees, we call them supplementary angles. So the first question is for 56, how can you find the complement of this angle? So to find the complement of the angle, all you have to do is 90 degrees minus 56. And this will give you 34 degrees as an answer, and this answer will go inside the first box. And then when you check your answer, the second part of the question will open up, and it's asking this time the supplementary angle. For the supplementary angle, you need to do 180 minus 56, and this will give you 124 degrees for the second box for this question. I have quite a bit of this example type. Even question 2 is the same style, complementary and supplementary angles. For complement of this angle, 67, you will do 90 minus 67, and it will be 23. For supplementary of the angle, you will do 180 minus 67, and you will end up with 113 degrees. So all these questions from 1 through 4, they are the same objective, finding the complementary angles and supplementary angles. Let's go to question 5. It is still the same idea of finding complementary angles and supplementary angles with a difference. This time, the given angle is 20 degrees, 15 minutes. So in order to find the complement of this angle for question 5, the way we're going to do is still the same. So I need to calculate 90 degree minus the given angle. And then the given angle is this time 20 degrees and 15 minutes. This is what I need to do. Now, because this is only degrees, but this is degrees and minutes, I'm going to rearrange this number. Instead of 90 degrees, I'm going to write it as 89 degrees and 60 minutes, because every 60 minutes is a degree. So there's some still a 90 degree, and I will minus 20 degrees and 15 minutes from this. We should really handle the minutes first. So if you subtract 15 minutes from 60 minutes, that gives me 45 minutes. And then I can do 89 minus 20, which will give me 69 degrees. And this is how I handle the first part about finding the complementary angle. For the supplementary angles, they add up to 180 degrees. So I need to perform 180 minus 20 degrees and 15 minutes. Again, I'm going to rewrite it as 179 degrees and 60 minutes. So I can perform this subtraction, 20 degrees and 15 minutes. So 60 minus 15 is just 45 minutes. And then 179 minus 20 is just 159 degrees. So that's how we find the answer for the part B on question 5. We will continue with question 6. For question 6, we're moving to a different concept, coterminal angles. So before we model some examples, let's talk about coterminal angles. They are very important in trig class. So I want to just first show you an example what they mean. When I need to draw angle 30 degrees, this is our unit circle chart, and it's very important to know where it starts and where it ends. So this x-axis is where your 0 degree will be located. So this is like 0 degree, and then this is your 90 degree. This will be your 180 degree. This is 270 degree. And then when you reach to this point where 0 lives, it's the same thing as 360 degrees. So 0 and 360, they represent the same location on the unit circle chart. So if we go back to our topic for 30 degrees, if I need to draw 30 degrees, this is the initial start point for 30 degree, and then this will be the ending ray for 30 degrees. So 30 degree is an angle, maybe this big. So its start line is at 0. This is the starting array, and this is the ending array, and this is what 30 degree is, okay? So 30 degrees and 390 degrees, we're going to call these two angles as coterminal angle because their terminal is going to end in the same line. So actually, let's just get a different color for 390. So for 390, I am going to start from the same line. This is my same line. So I'm going to make a full tour because one full tour is just 360, but I need to go further because I need to reach to the 390. So I'm at 360 here. If I go 30 more, I'm going to stop at the same line as 30 degree. And now I covered the 390 degrees distance. So if you look at this light green angle, which represents the final designation for 390 degrees, its terminal sides are the exact same sides as 30 degrees. So these are called coterminal angles. This is the geometric meaning of coterminal angles. If we need to understand how we're going to find coterminal angles, every time we need to find the coterminal angle to an angle, we're going to add or subtract 360 degree and its multiples. So to find the coterminal angle for 45 degrees, you can add 1 times 360. And then you can just find that 4 or 5 will be a coterminal angle with 45 degrees, okay? If this is not making you happy, instead of 360, because this is 1 times 360, you can actually add 2 times 360, which is 720 degrees. And then you can find another angle, which is 765. So all these angles, 765 degrees, 405 degrees, 45 degrees, they're going to all start at the same line and end at the same line as a angle array. Okay, so this is what their angle they're going to eventually look like. Even one of them is very big. For example, this one, it's going to make 2 tours, but still going to give you the same acute angle. And then this is just going to take a full turn. And then when it needs to go extra, it's going to just make the same acute angle. And 45, when you just draw your 45, you still have to start from here and end at here. And that's going to still represent your 45 degrees. You can add or subtract to find the coterminal angle, multiples of 360. After saying this, let's just open up some space here and then look at our question 6. So for question 6, find the measure in degrees not equal to the given measure of the least possible angle that is coterminal angle with angle A. So angle A is given 233 degrees. To find a coterminal angle with this, I want to just add 1 times 360 to this. And then when I add them up, the answer will be 593 degrees. That answer goes inside the box here as an answer. For question 7, we are going to find a similar question to this. We want to find the angle of least positive measure. So because they want the positive angle, I don't want to use my option to subtract 360. I want to just use my option to add 360 because I want to get a positive angle. So since negative 147 is given, and we're going to find the coterminal angle with this, I'm just going to add 360 to this. And then the answer will be, when you add a negative number with a positive number, you actually subtract them. So if I do the math mentally, I believe, and then this is big, so it's going to stay positive. I want to just double check my answer. 7 plus 3 is 10, 1 is decayed, 4 plus 9 is 13, so it doesn't work really. So I'm just going to then go ahead and do the subtraction here. I think if I didn't make a mistake this time, I believe like the expected answer will be 113 degrees. So let's just check this, maybe 213. Yes, I believe this time I did my number right. 7 plus 3 is 10, 4 plus 1 is 5, 1 is decayed is 6. And then this one, I am going to go ahead and put 213 degrees as an answer, and then I will check my answer. And then it'll be correct. Before we do the next question, I will also talk about what does this negative angle means in our class, in actual math in general. So it just represents the direction. So if you go back to my example about drawing 30 degrees on this coordinate plane, we said that this is always our starting point, 0 degree. If the angle is a positive angle, we're going to go this direction to get our terminal side. So because 30 degrees here is a positive angle, I'm just going to draw my terminal side here on this direction. And then this is going to represent the positive 30 degrees. So this angle here is the positive 30. But if I need to draw them a negative 30 on the same chart, my start is not going to change. I'm going to still start at 0. But because this time the angle is a negative angle, so I need to go to this negative direction. This is the negative direction. So I'm going to go open up my factor maybe about 30 degrees big. And then I'm going to stop here. So numerically, the scalar-wise, quantity-wise, it's still 30. But instead of having the angle in quadrant 1, we call this as quadrant 1. Very important in trig class to know where your quadrants are. This is our quadrant 1. This is our quadrant 2. And then this is our quadrant 3. And then this is our quadrant 4. So positive 30 degree lives in quadrant 1. But when I have to show them the negative 30 degree lives in quadrant 4. That's the difference between a positive angle and negative angle. So positive and negative shows you the direction whether you're going to go this counterclockwise or clockwise rotation. That's the explanation I wanted to give you about negative angles. So after we mention this, let's go back to the homework. This time we have 368 degrees. We want to find the angle of least positive measure, which is not equal to the given angle, and it will be coterminal with this. Because this is now more than 360, remember every time we take a tour around this thing, when we make a full tour, it's 360 degrees. Since the given angle is bigger than 360, I want to this time subtract 360 instead of adding to find the coterminal angle. And I want to find 8 degrees because 8 degrees is still a positive angle. And the question was specifying that they need a positive coterminal angle. So instead of adding, I can just give them, I can just subtract them and it will be 8. If you add 360 and you find a very big number like 728, the answer is still correct, but homework will mark it wrong because the homework is asking for least positive measure. So the least positive is 8, but if you add and give them a bigger number, it's still a coterminal angle, but that's not what they want. We're going to go to question 9 next. So for question 9, we want to find the coterminal angle, but it has to be positive measure. And then the given angle is negative 606. Now, because I want to give them a positive coterminal angle, so I'm going to go ahead and add 1 times 360. And then when I try to add 1 times 360, I know that this number is very big compared to this one. So the result will be still a negative 1. So instead of not doing the work again, what I'm going to do is, I don't want to just add 1 times 360. Instead of doing 1 times 360, I want to do 2 times 360. I want to add 720 to the given angle to find the coterminal angle. So I need to actually subtract these numbers. That will be 114. And then since this is a bigger number, the result will be a positive number. So I'm going to tell them that the first least positive coterminal angle will be 114 degrees. So again, rest of the questions are with coterminal angle. So if adding 2 times 360 is not enough, try 3 times 360 for question 11. I want to now model you guys question 12 here. So let's just open some room here. For question 12, Find the angle of least positive measure that is coterminal with 3,321. So since this is such a big number, 3,221, I want to find the coterminal. It needs to be positive and it needs to be the least. So I'm going to just keep thinking about my multiples of 360. We already know that 1 times 360 is just 360. So just subtracting 360 will not be enough. 2 times 360 is 720. This will not be enough still. 3 times 360 is 1080, and it will not be enough. 4 times 360, I believe that is 1440. That's a lot of numbers. So maybe 8 times 360 might do my work. So let's just multiply 360 by 8 first. 6 times 8 is 48, 4 is the carry, 3 times 8 is 24, 4 more is this. And then if you go ahead and subtract this, let's see if we're going to get a number which is less than 360. So I need to perform this subtraction. That's 1, 12 minus 8 is 4, and then 12 minus 8 is 4 again. That's it, 441. As you notice, this wasn't the right thing to subtract. I'm going to subtract 360 one more time because this is still more than 360. 14 minus 6 is 8, and then I believe that's it. So I'm going to tell them that the answer will be 81 for this question. That's how we can do the questions right. So question 13 is still a coterminal angle and it's negative this time. You know that you're going to add 360 maybe more than one time to find a coterminal angle. Now for question 14, it looks like it's a little bit different than what we have done so far. So let's read the question carefully. Find 2 positive and 2 negative coterminal angles that are closest to given quadrantal angle. So first of all, this vocabulary, quadrantal angle, like 90 degree is a quadrantal angle. So 90 degree, it starts from here, it ends in here. So this is like our y-axis, and then this is x-axis. So 90 degree is a quadrantal angle because its ending is on an axis. And then 180 degrees starts from here and goes all the way to here. It ends on a y-axis, so 180 degree is also a quadrantal angle. Another quadrantal angle is 270 degree, so it ends here. So as usual, it always starts from here just like any other angle, but it will end here for 270. So it ends on y-axis, so 270 is a quadrantal angle. That's what quadrantal angle means. So we want to find 2 positive and 2 negative angles for 180 degree. So for positive angles, I'm going to add a 360 to this. So it's going to give me a 540. So one of the positive angle I can give them is 540. We need to use a comma to separate the next answer. And then my other coterminal angle will be 2 times 360 will be added. So 720 needs to be added. And then when I add them up, the sum will make 900. So I'm going to put a 900 here. And I can check my answer. Then the next part of the question will happen. What if you need 2 negative coterminal angles? So that means instead of adding, this time we're going to subtract 360s from the given angle. So when I subtract 360 just once, 180 minus 360 is negative 180. To find another coterminal angle, I can also subtract 720 from the given angle. So if I subtract 180 from 720, I will get, I believe, 540. Let me see. 0 minus 0 is 12 minus 8 is 4. 6 minus 1 is 4. So I have 2 negative coterminal angles, which are negative 180 And then the other one is negative 540. And then I can check my answer to this. The last question is actually same as question 14 here for me, question 15. Since I don't want to practice the same number again, it doesn't allow us to regenerate this. Hopefully in your case, it's going to actually generate a different number than the same answer, so you can practice this question again. This is end of 1.1.